This short signal revealed something very big: the collision of two mammoth black holes.
The collision formed a larger black hole weighing a whopping 142 times the mass of the Sun, by far the largest black hole ever observed through gravitational wave detections.
Amazing enough, but something else has astounded scientists. The larger of the two original black holes, weighing in at 85 times the mass of the Sun, should be impossible. Why? Stellar black holes are formed by the collapse of a star, but stars with masses in the range of 65 to 135 times that of the Sun undergo a process called pair instability, resulting in them being blown apart, leaving nothing behind.
The larger of the two black holes involved in our collision falls squarely into that forbidden range and therefore should be impossible. So if it wasn't created through the collapse of a star, how did it form?
One theory is that it swept up other black holes through ongoing collisions.
So, if you like, this black hole contains a number of smaller black holes, like Russian dolls.
The collision detected by the LIGO and Virgo scientific collaboration happened when the universe was about 7 billion years old, around half its present age. It resulted in what's known as an intermediate mass black hole, heavier than the stellar black holes, but lighter than the supermassive ones often located at the centre of galaxies.
We were just so excited to achieve the first direct observation of an intermediate mass black hole in this mass range. It was incredible.
And we can expect more incredible moments as the sensitivity of gravitational wave detectors is further enhanced.
The Australian Academy of Science, because questions need answers.